want to first go over how to get properly set up to receive your signal. So first we're going to go to Audacity, the audio editor. Just Google it, go to the website. Go to the download selection. You'll find that there's a copy for Windows, Mac, and also Linux. And while the software is 32-bit, it will run on a 64-bit operating system. There's legacy downloads for older systems older than Windows 7. Now let's go to WebSDR website so that we can pull up the information there. So it's WebSDR.org. This is the interface, and it lists all the different stations that use a web interface with their software-defined radio. Scan through here, it shows the frequencies that are covered, as well as the antennas that are used with those systems. And we're specifically looking for stations that cover the 137 megahertz frequency range. Here's one in the Netherlands that has the range we need, and it's using a good antenna for reception. Here's a Russian station that I use quite often to collect the NOAA weather satellite signals from, and it has the range we need with a good antenna. And then here's one in Milford, Pennsylvania, US. So if you click on the link, it'll take you to the WebSDR interface, and you'll be presented with a series of frequency bands with a what's called a waterfall display. Here each of the NOAA satellites are already bookmarked, so it makes it easy to find the frequency you need if you don't know it off the top of your head. If you have problems with sound, make sure you read this up at the top. Chrome Explorer or Chrome web browser has problems with the sound. Or you can click the Chrome Audio Start button. If you want to set up a direct shortcut for it, you can go to More Tools and put a shortcut on your desktop to make it quick and easy to get to this particular WebSDR station, which I highly recommend. Here's where you enter your frequencies in. Notice it's in kilohertz, so you need to convert the megahertz frequencies by multiplying by 1,000 to get the correct kilohertz value. These are the different modulation modes. For the NOAA satellites, we'd be using the FM demodulator frequency mode. Here you can select just one band to limit the amount of memory usage on your computer. This is how you tune the little cursor. I usually zoom in and center the frequency of concern. And you need to also increase your bandwidth as far out as you possibly can by grabbing the edges of the cursor and dragging those out on both sides of your tune. Also make sure you don't have mute or squelch turned on so that you won't get the sound you need to record. You can record the audio, which is a really nice feature, and it starts collecting kilobyte sizes of the signal as it's being collected. Typically you would have about a 8 megabyte to a 12 megabyte for your satellite pass each time for the file size. When you hit stop, you can then download that file directly to your hard drive. Now let's go into the Orbitron satellite tracking software. Just Google it. Go to the website. This is the website we need. And this is information that talks about its features, capabilities. Its purpose is to track artificial satellites to let you know when they will pass certain portions of the Earth. It describes a little bit about what is satellite tracking. And the download locations are up here at the top. 2 locations you can select. There's also more features which are add-ons to the program, such as different map backgrounds. You can add clouds if you want to. Also, these are the TLEs, or 2-line elements file that you need to download and install along with it. These are used to accurately track the satellites, and they have to be updated on a periodic basis. So you see here I've got my shortcuts to the different stations on my desktop. Make it easy to click on and get to them rapidly depending on when the satellite is scheduled to pass. So opening up Orbitron, let's take a look at its interface. You get a world map showing satellites you've selected to monitor and track. It shows their path and then the radius of the signal around the individual satellites. If you go down to the location tab at the bottom is where you enter in your locations. There's a general world listing, but you can also set up a private list, which I've done for all the WebSDR radio stations. You'll need the latitude and longitude of the location, which you can look up on Google Earth or other means. Enter that in, enter the name of it, and click Add to List, and you can have it on there. Click on the item in the list and select Choose, and it will show that station in relation to where the satellites are. Again, just choosing the different ones. This is the Milford, Pennsylvania station. And then clicking on the individual satellite icon stars will show its path as well as its signal. You can select the individual satellites. I just basically have the NOAA and a couple of Russian satellites selected at this time. And this can be updated for any new satellites as well. The menu is kind of hidden way off to the right in a little icon. Here's the different menu items. You can load different profiles. Here's where you're going to update your TLE files as necessary. And I would say at least once a week, if not more frequently, depending on how accurate you want your tracking to be done. So typically to get set up to collect a signal, I have Orbitron set up and open, and then I go to the station that I know it'll be passing over, and I have these both open. Again, this is a little bit different interface, but basically everything's the same as far as the layout. You have the multiple band waterfall displays. The waterfall displays take up a lot of memory, so I would suggest for best performance not to have too much open on your computer while you're doing your satellite tracking and recording of signal. So we're going to enter in the frequency range we want for the particular satellite we're interested in. Again, don't forget it's in kilohertz, so if your value is in megahertz, you need to correct for that. Let's go back to the one band, so we're listing the one band of interest, which is the 137 megahertz frequency. You can go back and forth if you need to. This is kind of what some signals look like in relation to the waterfall display, which is basically data of frequency, intensity over time. So you can just click on the display and your cursor will go to whatever frequency you've selected. Typically I do that and then I start zooming in so I can see the signal properly, and I need to adjust for Doppler Shift, which is its satellite signal will start at a higher frequency than published as it approaches a WebSDR station, and then go to lower frequencies as it passes. So grab your cursor and drag out your bandwidth. You want the maximum bandwidth for collecting your signal from. Grabbing the center part is how you actually tune and how we'll manually move to keep the signal centered over the satellite signal as it approaches and passes. And then you set up by looking at your Orbitron tracking to get the satellite and when it will pass over the station of interest. So going back and putting in the frequency of the satellite that will be next coming up. So now we're kind of all set up. We have our frequency range selected. We have our Orbitron tracking software. We have our bandwidth expanded out as far as each station will allow it. And to make sure course mute is not on, or you can mute while you're waiting for the satellite to show up so you don't have to listen to the background static. There's a little radar blip that shows as new satellites approach into the map. So I'm just going back and forth showing the different WebSDR locations and which satellites are expected to pass over. You want to do this all up front prior to when you know that the satellite will come through. Here I'm going to go to an actual station where I expect a satellite to cross over. A little bit different interface. This is the Russian WebSDR. Enter in the frequency for the satellite we're interested in. This is the frequency for light. You'll notice that it's bookmarked already. Again, we want to grab display, the waterfall display, and drag it to center our signal, and then zoom in by hitting the plus button or zoom in button depending on which interface you're using. We want the FM demodulator mode, and then grab and drag your bandwidth out as far as it'll go. You need about a 30 kilohertz bandwidth minimum to collect a satellite signal. Not all stations will have that capability. Some have more. And then you adjust your frequency, as I just showed, to a higher frequency, and then you pull up Orbitron and look for your satellite to approach. That's kind of how you get all set up to collect your signal. Typically, I expect the signal to show up on the waterfall display at about 1,800 mile range from the station.